Today we are going to solve the problem 3.12 of Griffith third edition Introduction to Quantum Mechanics. The problem 3.12 is find the pi of p and t, that is position and time dependent wave function for the free particle in terms of function pi of k introduced in the equation 2.101, so that for a free particle the modulus pi squared is independent of time. The comment is the time independence of pi p and t modulus square for a free particle is manifesting of the momentum conservation in this system. According to equation 2.101, psi of x and t is equal to 1 over square root of 2 pi integral between minus infinite to plus infinite pi of k multiplied by e power I kx minus omega t tk. Here, remember that we are carrying out the integral using k, so not x. Here integral is with respect to k. The momentum phase wave function is given by definition. Pi of p and t is equal to 1 over square root of 2 pi h cross integral between minus infinite to plus infinite psi of x and t e power minus I p x over h cross. Here I have rewritten that is e power, actually this is e power I kx minus I kx. So I am replacing k as p by h cross, as h cross k is equal to p in quantum mechanics. So I have replaced k by p over h cross. Now what is psi of x and t? You see this yellow color band. I have replaced the psi of x and t, the term using the yellow color band, that is 1 over 2 pi square root of 2 pi integral between minus infinite to plus infinite psi of k e power I kx minus omega t tk. Here integration is with respect to k. Already you have this integral between plus infinite to minus infinite, which I have shown in green color. Then I have taken this out, e power minus I px over h cross. This part of integral I am going to carry out using x. Now we will try to simplify this integration. Now we got this expression. Here what we are going to do is you take out all the constant term outside the integral. That is 1 over square root of 2 pi h cross, and this is here 1 over square root of 2 pi. I have used yellow color, and also here you can take this omega t. E power minus I omega t is not depends on either k or x. So I can take it out. E power minus I omega t. Then this integral outside. Integral between minus infinite to plus infinite. And this one. This sorry, this one, this exponential term. This is e power ikx. Sorry, this is, I will spend little bit time here. And this exponential term. Both contain tx. Here also the x dependent, here also x dependent. You combine this exponential term. Of course, ignoring this I omega t, because we have taken e power minus I omega t outside. So you will get e power I kx. here minus p over h cross, minus p over h cross. I have taken I outside, and in fourth term here also you have x, here also you have x. So I have taken x outside. So I bring this tx here, and I have brought tk outside, because only the psi k contain k dependence. So only k dependence. So I am taking that out. Sorry, pi of k. Pi of k is only k dependent. So I have taken that outside this integral. So pi of k with respect to tk. First, you carry out this integral. This value of this integral is this, which I have shown here. 2 pi is a delta function. By definition is a delta function. That is k minus p x, sorry, p over h cross. So we have taken this argument without I and x. So this is by definition is a delta function with a multiplicative factor 2 pi. So this is 2 pi delta k minus p over h cross, and we have taken psi of k tk outside. So this one integral is gone away. So we have to carry out this integral, second one, that is minus infinite to plus infinite. 2 pi, this delta function, and psi of k, we have to integrate with respect to k. Now we will do that. Now we got this expression. Here we can do some simplification. Here you have square root of 2 pi, and here also square root of 2 pi. So if you multiply both, you will get 2 pi. So this will get cancelled with this 2 pi. So ultimately you have here 1 over square root of h cross, 1 over square root of h cross, and this exponential term. And what about this integral? You will have non-zero term only when p equal to p over h cross. That is, delta function must be equal to 0. When delta is 0, you have non-zero value 1. Otherwise, it will be 0. So you will have only non-zero value if k is equal to p over h cross. So I am rewriting, replacing k by p over h cross. Now you take modulus square of uh, pi. That is it. This is the expression which depends on both momentum and the time. That is pi of p and t is equal to 1 over square root of h cross, then this exponential term, and pi, which is a function of p over h cross. If you take modulus square of this, naturally, if you take modulus square, this will become e power minus I omega t into e power plus I omega t. If you take complex conjugate, if you multiply both, you will get 1. So naturally this term will go away. If you square it, you will get 1 over h cross, and this is pi, which is a function of p and p over h cross modulus square. So you can see the left hand side is time dependent, the right hand side is no time dependent. So if you take modulus square of pi of p and t, you will get a time dependent term, which is independent of time. So we have solved this problem. If you find this lecture helpful one, kindly subscribe. Don't forget to share my videos and join my channel for the growth of my channel. Thank you very much for watching my video and supporting me continuously. Thank you very much.